In this episode of Scaling Postgres, we talk about lateral joins, generating JSON, dbcritic, and fetch first rows. I'm Preston Jamison, and this is Scaling Postgres, episode 174. All right, I hope you, your friends, family, and coworkers continue to do well. Our first piece of content is understanding lateral joins in PostgreSQL. This is from cybertech-postgresql.com, and they're talking about lateral joins. Now, I really like this blog post from the perspective of how they explained lateral joins. They took an example here of you have a select statement that you would send to Postgres that select whatever columns from a particular table called tab. Well, you could think of this as a for loop in a programming language. Basically, for every instance of tab, assume it's an array of something, you're going to loop over it and grab data from each instance of the array. So now what is a lateral join? Well, a lateral join is basically a nested loop. So you want some set of data, and then within that set of data or that instance in an array or row in a table, you want additional items of data from another table. So they have this following example where you have a set of products and they set up 1,000 products with particular prices. They set up a wish list table and inserted 3 individuals with the desired price for a particular product for each of these individuals. And this is what the 1,000 products basically look like and what the wish list looks like. So going back to thinking of a select statement as a loop, essentially you are going to loop over each item in the wish list, and then you're going to loop over the products, looking for the case where it's a certain price, and returning 3 of those items. And that's essentially what the lateral join does. So you're selecting from the wish list table, then you're doing a lateral join to this query or subset of a table. So it's a query with a product table where the price is lower than the desired price on wish list. They're ordering by the price and giving you a limit of 3. So each wish list is shown along with 3 prices that are below the target price. So basically these first 3 columns come from the wish list and the remaining columns come from the product table. And that's all a lateral join is. It's basically a nested loop. And when you do an explain of the plan, you can see that it is indeed doing a nested loop. So that's all that a lateral join is and what this post covers. And it kind of makes me think, should they have perhaps renamed lateral join in the SQL standard? But if you want to learn more, check out this blog post. The next piece of content, cut out the middle tier, generating JSON directly from Postgres. This is from crunchydata.com, and they're talking about using functions that exist within Postgres to actually return JSON to your application. So as opposed to just generating the normal output that you typically receive, you output it as JSON. So they have an example of here where they have employees and departments, so employees belonging to departments. And the first function they show is called row to JSON. So you can give it a single row of data. Here they're selecting from where the employee ID is 1, and it will output in JSON each of the columns in that row. And then it does something interesting here with the geometry column where it actually nests some JSON because they have a custom type set up that casts it to JSON. So it automatically does this. Now what you're generally going to want to do is outdate rows of JSON essentially, or an array of JSON objects. And that's what JSON AGG or the JSON aggregate function does. So here as a subquery, just selecting the employee ID and the name from the employees table where the department ID equals 1, and then doing a JSON aggregate on that output shows you the JSON that you see here, an array of 2 essentially JSON objects or JSON entities. And you can even nest the output. So here's an example using a CTE where they're selecting the data they want from the employees table, then they're joining it to the departments, and they're including in the output an aggregate of the employees for each department. And then the last section of the CTE aggregates all of the departments that are being selected. So you can see it generates the JSON as you see here, where you have departments and each employee in those departments for each object. Now, the benefits of doing this in your application are definitely speed, because if you're using an application framework such as Django or Rails or any other, usually those use ORMs. And there's a lot of overhead using that ORM, generating objects for each of the returned pieces of data and returning it to the user. Going directly to JSON is much faster and should give you better performance. So if you're interested in that, definitely check out this blog post. The next piece of content, dbcritic, constructively criticizing your Postgres schema using Idris. Now this is from Channable.com, and they're talking about how they wanted to help audit how they were setting up their database schema and give guidance on some best practices. So they created this solution called dbcritic. I've heard of other language critics such as RubyCritic, basically criticizes how you're writing Ruby. So you run this against your code to give you an output of it. Well, this does it for your Postgres schema. Now, right now, they're only criticizing two areas. The first area they're mentioning is having an index on your foreign keys. Now, the importance of this is for when you go to, say, delete, in this example here, an add. So if you want to delete one add, if it has a foreign key, it's going to need to look at add statuses by this AD ID to delete those as well. And without an index, that's going to be slow. And it'll be really slow if you need to delete multiple adds that then each has multiple statuses. So the time increases dramatically. But if you have an index on this AD ID column, it should be able to delete those much faster. And that's one of the things that dbcritic criticizes. The other one is mistakenly using timestamp when you wanted timestamp that includes the time zone, so timestamp TZ. So basically it does an audit of your schema to make sure that all of your timestamps are timestamp TZ. So those are some of the areas that dbcritic covers now, and they have integrated into their CI pipeline. Now, it's an interesting project, but it is written in Idris, which they say is a functional programming language similar to Haskell. I've never used it before, so I think that would probably be the only thing that would give me pause about using this at this time. But these types of audits should be relatively easy to implement in other languages. So if you're interested in auditing your Postgres schema, maybe you can take some of the suggestions from this post and implement them yourself. The next piece of content, PostgreSQL, limit versus fetch first rows with ties. This is from cyberduck-postgresql.com. And they're talking about how Postgres allows you to limit to return only a certain number of rows from a query. But the actual SQL standard is to use fetch first rows. So for example, if you want to use limit in this query with 7 rows, you could say limit 3 and it returns you 3 rows. You could also use fetch first 3 rows only and it will return you the exact same thing limit would. So it is more verbose, but it is the SQL standard. Now, they also cover with ties. So this is something you cannot do with limit, but you can do with fetch first rows. So when you specify fetch the first 3 rows with ties, what it will do is not just give you the first 3 rows, but it will include additional rows that would have been equal to the last one. So if you look at the table they initially implemented up here, they have 3 appearing twice. They also have 4 appearing twice. So that's the data in the table. When you fetch only 3 rows without ties, it's going to fetch these first 3. But when you fetch it with ties, it will fetch 4 of them. And then if you actually add another 2 row to it and you do fetch first 3 rows with ties, it will then give you 1, 2, 2 because it won't retrieve the 3 anymore. Now, as long as you're ordering by the ID when you fetch first 4 rows, you're going to get that repeated row here, so the 5 rows. But if you order by the ID and then this random column, you're only going to get 4 rows, even though you're doing with ties. So that's something to keep in mind. The order by clause is very important when using the with ties. So this is another great blog post. Go ahead and check it out if you're interested in learning more. The next piece of content, what happens to logical replication after running PG upgrade? This is from elephanttamer.net. And they're talking about a scenario where they have a large active database that's doing logical replication to another database, as well as maybe even doing some logical decoding. So it's very active. A lot of queries and statements are being run, and you want to upgrade them to the next version. So the issue that you will encounter is that if you need to use PG upgrade to do that upgrade, because that's the fastest way to do it generally, is that PG upgrade will destroy all the replication slots. So you're going to lose any logical replication going on. So it's critical to have those replication slots back in place before you allow any more traffic at all to the main database system. So he's worked out a process to do these types of upgrades. So the first step is to block all traffic to the primary database. And he does this by altering the PG HBI comp file, or you could alter your firewall settings. The second step is that wait till the replication lag is 0 and then drop the subscription on the subscriber, which will also drop the publisher's replication slot. Then you do your upgrade on the subscriber, do the upgrade on the publisher, and then the next thing is on the subscriber, create the subscription again. But you do it with copy data equals false because the data should already exist there. Then you do a smoke test to make sure that logical replication is working. So you insert some data, make sure it gets replicated, and then go ahead and remove it. Then you can create any other logical replication slots that are required, and then you unlock the write traffic. So this is a process that worked for him. He did mention that there's also the ability to alter the subscription and set a new replication slot, but he had some issues getting this working with his upgrade procedures. So if you use logical replication and need to upgrade your database, maybe you want to check out this post to follow his suggested procedures. The next piece of content, Secrets of PSQL, a Great Tool. This is a YouTube video on the San Francisco Bay Area PostgreSQL users group. And this is a great post talking about using PSQL, the command line tool, because if you're going to be using a lot of Postgres, it's a great tool to get to learn all the ins and outs of. And this presentation does a really good job of doing that. The next piece of content, how much data goes into the WALs? This is from fluca1978.github.io. And this post first covers a lot about the WAL, basically the write-ahead log of Postgres that basically records all data changes to Postgres, and then eventually they get written to the actual data files. And he talks about the existence of the WAL files, how they're set up, and how they have log sequence numbers within them that reference different areas of the log, including some utilities you can use to inspect the log. So this is a good post of explaining a lot of that to begin with, but then he goes into talk about how WAL gets generated. And when you insert data into the table, you can see how much WAL is generated given different types of inserts, and how if you have an unlogged table, you're basically not going to get any WAL generated from any changes made to particular tables. So if you want to learn more about the WAL and how it works, definitely check out this blog post. The next piece of content, improved logging by libpq in PostgreSQL 14. This is from postgresql.fastware.com. They're talking about some enhancements to 14 with the client-server communications and to be able to trace what's going on, and that they have added some timestamps for you to be able to debug different issues in client-server communication. So if you're interested in that, definitely check out this blog post. The next piece of content, first contact with the PG file dump. This is from hygo.ca, and they're talking about using a utility to inspect Postgres' data files. So for example, he created a table, inserted 3 rows into that table, then identified what file exists by using the PG relation file path function to identify where a file is, and then used PG file dump to run against that file. So now you can inspect the header block for that table, look at individual data items and the different parameters and how they work to inspect Postgres. So if you're interested in learning more about the internals of Postgres, you can definitely check out this blog post. The next piece of content, logical replication of in-progress transactions. This is from amitkapila16.blogspot.com. And in Postgres 14, they released some enhancements to be able to start sending data to a logical replication subscriber before a transaction is all the way committed. So generally, in versions earlier than 14, you needed to wait till the commit happened until information started transferring to subscribers. But if you have a lot of activity going on in a transaction, that's less than ideal. So they've started a way to be able to start streaming changes before they're actually committed in Postgres 14 and higher. And this blog post walks through the description of the feature, all the changes they had to make in order to make it work in Postgres, as well as some of the contributors to it. So if you're interested in that, you can check out this blog post. The next piece of content is the PostgreSQL Person of the Week is Jean-Christophe Arnu. So if you're interested in learning more about Jean-Christophe and his contributions to Postgres, definitely check out this blog post. And the last piece of content, this past week, the Rubberduck Dev Show gave a presentation on pair programming. So if you want to learn the whens, whys, and hows of pair programming, you can check out this episode. This coming week, we're going to be discussing object-oriented versus functional programming. So be sure to join us on Wednesday, 8 p.m. Eastern Standard Time. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.